Okay, here we go, 6.4. We're talking today about solving linear inequalities using addition and subtraction. So again, this is a bit of a shorter lesson. We're just going to focus on sort of one way to solve inequalities, and we can solve inequalities similar to how we solve equations. And this kind of first level of solving inequalities is pretty basic. Can we maybe grab those lights? It might be a little washed out there. So first thing I want to do is I want to compare an equation with an equality. And I've shown you here in your notes that you should have open in front of you that this is the way we solve an equation. So remember, if we have h plus 3 equals 5, we want to isolate the variable, okay? And in doing that, I'm going to subtract 3 from both sides. So I'm going to subtract 3 from both sides. I'm going to get h by itself on the left, and over here we have 5 minus 3 is 2. So when it's all said and done, I have h all by itself. It's positive, it's in the numerator, there's no fraction, it's not in the bottom of a fraction. It's all by itself and positive in the numerator, so I'm done. I know that h is 2. I can check that, okay? And I should check that. If I put 2, so verify or check is something that you should always do, and I have one solution that I'm going to check. So 2 plus 3 should equal 5 if my answer is correct. So I put it into the original equation here. Is 2 plus 3 equals 5? Does that equal 5? Yes, it does. Okay, so it has been checked. There is one solution. That solution is 2. Now, we said about inequalities that inequalities, there's not just one solution. There's a number of solutions. In fact, there's an infinite number of solutions. Now, we don't mention this word much in grade 9 math, but as you move through your math classes, as you get older and older, and as you get into calculus, we're going to talk about infinity a lot. That is an important part of calculus. So I'm going to be talking about that a lot. But if you think about it, is there one answer? No. Is there two? No, there's more than that. Is there a million? Are there a million answers to an inequality? For example, if I have h plus 3 is less than 5, and I know that one of those answers could be 0, because 0 plus 3 is less than 5, and I know one of those answers could be negative 10, I know one of those answers could be negative a million, I could keep listing answers indefinitely, right? So that means there's a whole range of numbers that would be solutions for an inequality. So how do we find out what the actual solutions would be if we have some kind of inequality that we have to solve? Well, the good thing is when there's only addition and subtraction involved, it's exactly the same as an equation. It's exactly the same. So that's really cool. So if I have h plus 3 is less than 5 instead of equal to 5, I go ahead and I do everything that's exactly the same. So I'll try and have maybe both up on the screen so you can see. But I would isolate for h, just like I did before, isolate, which means I subtract 3 from both sides. Therefore, plus 3 minus 3 gives us 0. So that's going to be h plus 0 on the left side. And I have 5 minus 3 is 2 on the right side. And the sign here stays exactly the same. So if it's a less than sign at the beginning, it just stays a less than sign. So if we verify this by choosing a number, and I'll choose, let's say h is 0, like I mentioned before, does 0, I'll do it down here, does 0 plus 3, is that less than 5? Well, 3 is less than 5, right? So that checks out. And you could check any number you want, any number that, again, is less than 2. So 0 is less than 2, negative 3 is less than 2, negative a million is less than 2. All right? So the rules are the same as equations when you're dealing with addition and subtraction only, and those are the types of questions we're going to do today. So let's get to an example. Any questions on that, though? Any questions? Okay. The rules are the same as we've done for equations, so it should be pretty straightforward. It just looks a little funny. This looks a little confusing maybe, right? When you have this inequality sign and you have like what looks like an equation with many terms, so it's an inequality with many terms, we just gather all the like terms like we would normally do. So if you look at this example 1, I want to get x all by itself. Now you can get x on the left side or the right side. I would suggest that you try and just leave x alone wherever it is right now for these questions, okay? Just leave it on the left side or leave it on the right side. I'll show you, if you don't like it on the right side, some people don't, you can move it to the left side and I'll show you how to do that. But let's isolate for x. So I'm going to add 4.5 here to both sides, okay? So let me just rewrite this. 6.2, I'm going to add 4.5. I'm going to add 4.5. So we did this exactly the same way that we would do an equation. And I'm left with x over here by itself. I'm not going to change this sign or move this sign around. I'm going to leave it as it is. And 6.2 plus 4.5 is going to be what, 10.7? Okay, 6 plus 2 plus 4.5. Now, remember what we talked about last lesson, that if you have x on the left side or the right side, you read the inequality from wherever x is. So I would read this as x is greater than or equal to 10.7. Now that, I know that's maybe difficult for some of you because you look at this sign and say, hey, that's a less than sign. Well, it is a less than or equal to sign, but it means that 10.7 is less than or equal to x. That means 10 is less than or equal to all of the answers that are possible. So really, you should read it from the variable. And if you don't like that, you can switch everything around. Now, this is where it gets a little bit tricky, but if you want to switch it around so the variable, let's say this is the variable over here, if you want to switch it around that the variable is on the other side, then you just have to change the sign around if you flip everything. So this is the same as x is greater than or equal to 10.7. Okay? So these two are the same. They're the same. And if you like putting x on the left side always, then you can do that. But if you don't change any signs, we're just literally flipping the inequality. So everything goes, the signs change, the numbers go to the other side, and you can read it like this as well. Okay? So let's graph and verify. So graphing this, I'm going to put a number line. I'm going to put 10.7 on the number line. That's where it is there. I'm going to put 0 over here because that's where it maybe would be in relation. And then because x is greater than or equal to 10.7, I'm going to put a, should I put a hollow circle or a solid one? Solid, very good. And should this arrow go to the right or to the left? Shout it out. Yeah, right, because x is greater than 10.7. So all of the possible solutions are greater than. And with an arrow like that, it means any number that's on that side of 10.7. So that's where you get your infinite number of solutions. Verify is the same as kind of check. So for an inequality, all you have to do is pick one number just to check, okay? So pick one number that's greater than 10, and we'll all probably, out of our head, maybe pick a different number. It doesn't matter. But I'm going to check x equals 12, okay? Because that one is over here, right? 12. So I'm going to check, see if that works. Okay, I'm going to use the original, this one right here. So 10.7, is that less than or equal to 12? Well, yeah, it's less than 12, right? So that checks out. And if you wrote it the other way, is 12 greater than or equal to 10.7? Yeah, it's greater than. So whichever way you write that, it works out. So read from the variable always. That would be my suggestion. Any questions about that one? Because that's really what the lesson is all about here today. These kind of three things here, and moving terms around. Question? Okay. Okay, let's try example 2. So let's solve and graph this one. So I see that C here is positive on the left side. That's great. So I'm going to leave it over there on the left side because I like it positive. But I'm going to get rid of this 4.8. So this is a positive 4.8 that's being added to C. So I'm going to subtract 4.8 from both sides. Subtract 4.8. Which eliminates the 4.8 from the left side. I'm left with C only. I'm going to leave that sign just the way it is, greater than. And when I combine these two terms, I have a negative 3.2 and a negative 4.8 is going to be negative 8.0, looks like. Negative 8.0. Okay. So I've got C all by itself, and it's positive, so that's perfect. And I can read this as C is greater than negative 8.0. So graph it. Let's make our number line. I would suggest that you put the number that's in the inequality on there, negative 8. I would also suggest that you put a 0 there. The reason is because you don't want to get confused as to, which way your arrow's going. It's going to help a lot if you have a 0 there. So C is greater than -8. So greater than means to the right on the number line, okay? So I have an open circle here because there's no or equal to, and then I'm going to draw my arrow to the right. Now, do you agree with that? Does that seem to make sense? Yeah? Okay, so let's verify real quick. 0 I see is in this region. So is 0 greater than -8? Yeah, -8 is pretty small because it's in the negative area. So anything above that, 0 or 10 or 1,000,000, that's all greater than -8. Okay? Questions? Let's do a word problem, and then we'll be mostly done this lesson. Okay? Word problem. All right. So Jake plans to board his dog while he is away on vacation. Oh, that's pretty small. Choose a variable and write an expression for each. Okay, so the boarding house charges $90 plus $5 per day. So we remember from equations that $90 here in this case would be a flat rate. So you bring your dog, they say yes, they'll take care of your dog. You owe $90 right there. Okay? Just for them saying yes, they'll take your dog. And then it depends on how long you leave it after that is how much more money you owe, $5 per day. So let's choose a variable for each and write an expression for each. So a boarding house charges $90 plus $5 per day. So let's say that D is going to be days, okay? Because that is what the cost depends upon, days. So it depends upon this rate plus 5 per day, okay? So 90, the expression for this is going to be $90 plus something. What's it going to be plus? Any ideas?
5.
Plus 5?
And then with the variable.
And then with the variable somewhere?
Yeah, behind.
Behind it? Okay, what's the variable?
D.
D, right. 90 plus 5D. Excellent. That is the expression for this boarding house here. $90 plus $5 times the number of days that the dog is there. Good? Okay. What about this one? Boarding house B charges $100 plus $4 per day. Well, if we had D equals days again, then we'll put $100 for the flat fee, and then we'll add $4 per day. Okay, now again, that's an expression for each, right? That's an expression. We have no inequality yet. But let's now think about the question that says, for how many days must Jake board his house in-house? Must board his house? I think that's supposed to be board his dog. In house A, so that should be dog here. For how many days must Jake board his dog in house A for it to be less expensive than house B? Okay. Okay, so I need to find out a D, number of days, where A is less expensive than B. Okay, so remember, this is the cost of house A. Cost of A. This is the expression for the cost of B. So I want house A to be less expensive than house B. So an inequality might be house A is less than B. And I want to write the actual cost. So I'm going to write 90 plus 5D is less than 100 plus 4D. Okay? So when you write this equality, you can still solve for D here, right? And that's what we want to do. We want to solve for D to find out how many days makes this cost less than this cost. So we can solve an equation to find out where the cost would be equal, or we can solve an inequality to find out where the cost could be less or more of something. So that's the slight difference in this, this type of problem. So let's solve the problem. Okay. So you notice that you have d's on both sides of the inequality sign there. So let's get all the d's together. What do you think? Let's get the d's together. So I'm going to subtract 4d from this side of the equation, guys, because I want to get all the d's together. So let's do that. D, and sort of inequality, I said equation, from the inequality. So I'm going to have now, on the left side, 90. What's 5d minus 4d? Plus 1d, right? Is less than, what's left over here? 100. Good? So I want to get d all by itself, so I have one more job to do. I'm going to subtract 90, because I don't want the 90s over here. And what I do to one side, I have to do to the other. So d is going to be less than, what is 100 minus 90? 10. Okay. So I've solved for d, which says that d is anything less than 10. Okay. Now, the context of this problem, what we did was we said, how many days would the cost of A, be less than the cost of B? So I guess what it says here is that if you put your dog in, this kennel for anything less than 10 days, then A is going to be cheaper. But if the dog is there for more than 10 days, I guess that this inequality is not going to be true. So it's going to be, this is going to be more expensive. This one's going to be more expensive, this one over here. Okay? Any thoughts on that? Questions? So let's write a word sentence. So if Jake's dog is in kennel A, I guess it's boarding house, whatever, kennel A, for less than 10 days, A is cheaper. A couple obvious things that you want to note about this is that D has to be less than 10, yes, but can D be a negative number? Can D be a negative number in this problem?
Well, you can't stay for negative days.
You can't go somewhere for a negative amount of time, right? So that doesn't really work. So it would have to be between 0 and 10, maybe, right? So that's one thing that's assumed that you'll have to kind of understand. So if someone said, okay, I'm going to put him in there for negative 5 days, and then the kennel's going to owe me money. That doesn't really work. Phone somebody up. My dog's been there for negative 5 days. I think you owe me some money. Sorry?
But if you answer like that, like on a test or like an assignment,
Yes, if you answered like that on a test or assignment, wrong. Yeah. Yeah. You said, for example, one of the solutions would be if the dog was there for negative 2 days.
if you did like
Then that wouldn't work because you're not understanding the context of the problem. So yeah, so that's what I'm saying. You'll have to kind of understand that in this situation, the dog can't be there for less than 0 days. Yeah, if you answer in a sentence, it shouldn't be a problem. That's right. Question?
could you just put like another like
Okay, so let's do a few more examples. I wanna see if you guys can do these ones on your own. Okay, so these ones are there's 4 examples here. I want you to write those down somewhere on your page or on a separate piece of page. Just use a section of the page that is a little bit empty there. And there should be kind of half your page that's free. So write these down. I want you to show your work. I want you to circle your answers. And I'll give you a few minutes to do these, and then we'll talk about them in a few minutes, okay? Okay, I'll do the first one with you if anyone's having trouble. But again, look back to an example. So I'm actually going to subtract 2 from both sides to get rid of this 2 over here. So what I do to one side, I have to do to the other. What I would suggest that I'd like you to do is to check. So just check with one number to see if it's valid. So x must be less than or equal to 1. So you can check 1 or anything that's less than that, like 0 or something like that. It's frozen? Okay. Well. So if you checked with something like 0, let's see if 0 plus 2 is less than or equal to 3. Is 2 less than or equal to 3? You examine that and you say, yeah, 2 is less than 3. So that seems to work. So here's your answer. Okay, go ahead and continue with the others. So there's the answer number 2. W is greater than 18. The third one here, we have x's on both sides. So we've had questions like that before. But right now, what you want to do is you want to make sure that you move the x's to one side where the x's are positive, okay? So you want to make sure the x's are positive. We're going to talk about multiplying and dividing to solve. That's going to be next lesson. So right now, what I would suggest you do is that you subtract x from both sides here. Why? Because the x is going to be a positive x on this side, okay? And then, so we're going to have something like this. We're going to have 3 less than or equal to 2x minus x is just x plus 7. You see that? So x is positive. That's what you want. Now, if you subtracted 2x from both sides and you got a negative x, again, that one we'll deal more with in the next lesson. There is a way to figure out that one as well, but we'll talk about that tomorrow. So in this case, though, you can get x by itself in positive. So we'll subtract 7 from both sides. And then we'll have x is, and I'll read it from x is greater than or equal to, looks like negative 4. Anybody get negative 4 for an answer? All right, let's check to see if that works. So negative 4 plus, yeah, I could do negative 4, I guess, because it's equal to. Let's check. Negative 4 plus 3 is less than or equal to 2 times negative 4 plus 7. Negative 4 plus 3 is negative 1. Is that less than or equal to negative 8 plus 7? Well, that's negative 1 and that's negative 1. So it is less than or equal to, it is equal to. And you could check another number that for sure is greater than negative 4 there, 2, to confirm. But I think I'm happy with this one. You guys agree? You guys okay with that? All right. Okay, what about this last one? Well, the last one, we have some distribution to do. So don't forget what we did with the equations. We have to multiply this in. So one little extra step. This is going to be 6. 2 times 3 is 6. Minus 2k is less than or equal to 0. Okay. Okay, well, let's see. This one is going to involve some multiplication or division. So maybe you tried this one. Maybe you got stuck. So this is what we're going to focus on tomorrow, but I'm going to move the k term over here, plus 2k to both sides. 6 is less than or equal to positive 2k. Okay. So what do you think? What do you think you would do here? So many of you, this is going to be a focus of tomorrow's lesson, but what do you think you could do here, given what we've done all class? Do you think it would be similar to what we did before or something different? What do you think?
Put 2k over 2 and then 6 over 2.
Okay, so you're saying let's divide by 2 to get k all by itself like we did with an equation. Let's see if that works. Okay, let's see if that works. So if I do divide by 2, that's going to be k all by itself here is greater than or equal to 3. Now, here's where the check is going to be important, because this is the first time we've done one like this. So I'm going to check this. So let's say a greater number than 3 would be 5. So let's do 2 times 3 minus 5 is less than or equal to 0. That's going to be 2 times negative 2. So that's going to be negative 4 is less than or equal to 0. Is that true? Yeah, negative 4 is less than 0. So that is true. So this is the correct answer. And good job, because that is going to lead us into tomorrow's lesson where we talk about more multiplying and dividing. It's very similar. There's one catch tomorrow that I'll teach you about when we multiply and divide inequalities. Okay. Any questions about those 4? Any questions about those 4? All right. So your assignment today from 6.4, I'll give you that in a second here.